Next video, I want to show you just a couple quick, easy examples on how to find missing side lengths. So 3a, find the value of x around the nearest tenth if possible, or if necessary. So first thing I'm looking at is I know I have a right triangle, so that means I can use my trig ideas of SOHCAHTOA and Pythag to help us solve these. I can't use Pythagorean theorem to find this missing side length because in order to find the missing side length using Pythagorean theorem, you have to know 2 out of 3 sides, and we still don't know this side, so we have 2 sides that we don't know. Therefore, we can't use Pythagorean theorem, so we'll use the other concepts, and that is we can use our ideas of SOHCAHTOA. Now I'm going to look through the eyes of this 53-degree angle. If I look through the eyes of that 53-degree angle, then this is the opposite side, and I'm being asked to find the hypotenuse. So I've got to apply the correct trig ratio. And if I'm looking at this, I got the words opposite and hypotenuse. That tells me, if I understand the definition of sine, cosine, tangent, and those other 3, that I'm going to need to use the sine of a 53-degree angle. This is going to equal the opposite side, which is 15 over x. So the first thing I do is I kind of get it set up so I know what trig function I'm going to need to use by applying the labels on the triangle. So this was, again, the opposite side. This was the hypotenuse side I'm trying to find. And this time I know the angle. So we always take the sine, cosine, tangent, or whatever of the angle. So I put the angle in here. The sine of 53 degrees equals 15 over x. Now to solve for x, remember these are a little trickery. You want to make sure you want to get rid of dividing by x, so multiply by x. So we have x times the sine of a 53-degree angle. And that'll always be in parentheses. You'll notice that in your calculator, as soon as you type it in, you always get a set of parentheses that come with it. In order to get rid of multiplying by the sine of 53, we divide by the sine of 53. So it's going to be 15 divided by the sine of 53. Okay, so we're going to run the mathematics on our calculator, and we'll take 15, and we'll divide it by, and this is what I mean. As soon as you hit sine, you notice you got a parenthesis there. That is an involuble argument, which means you cannot separate a sine from that 53 without using proper inverse sine key. Close it so it's syntactically syntax correct, and then I'm going to hit enter, and I forgot to check to see if I was in radian or degrees. So one of the things I want to check whenever I'm working with trig, I'm going to go back to the mode on this calculator and see how it says it's in radian. It gave me a radian measurement. Normally when we're working with triangles, we're dealing with degrees, so I got to run that calculation again. So that's something that I should have checked earlier and I forgot. Now I'm going to do the exact same calculation, and this time it's an 18.8 degree angle. So we're to the nearest tenth, 18 point, and again with my perfect memory I forgot 7/8, which makes it 18.8 degree angle. Oh my goodness, why am I saying angle? 18.8 is the length of the missing side. And something to be careful with, whenever you look at this side length, since it's the hypotenuse, make sure it's longer than your other side that you're working with. Okay, and then in our other example, we're going to find side x. So again, I'm going to look through the eyes of this angle of a 21 degree. This is opposite is the 9. The side that I'm trying to find is the adjacent. So whenever I got opposite adjacent, I'm thinking the tangent. So the tangent of a 21 degree angle has to equal the opposite side length over the adjacent side length. Then you solve the resulting equation. So we've got x times the tangent of 21 has to equal 9, which means x has to equal 9 divided by the tangent of 21. And we run our calculation around to the nearest tenth. It'll tell us our missing side length. So again, I'll grab the calculator, and it'll be 9 divided by the tangent of 21 degrees, close the parenthesis, enter, and why don't we actually hit divided by? So 9 divided by tangent of 21, enter, and that should be a better number. 23.4 would be to the nearest tenth. 23.4. So just a quick demonstration of how we can use our trig ratios to find missing side lengths, just applying your definitions of sine, cosine, and tangent.